Okay, cool. Hi everyone, my name is Shao, and today I'll be presenting to you an overview of what operational container scanning is. Right, so before we start, let me just share my screen. I created a simple slide to illustrate how things work. Just moving things around. Cool. Okay. So OCS, in short, stands for Operational Container Scanning. I was working on a feature for this. I was working on a migration for this feature in the last 2 months, essentially to move um, Starboard Operator, which is the underlying scanner, which has been deprecated, to Privy right? That's the implementation. I won't really be going through the implementation today, but I thought since it's fresh on my mind, it'd be good to give an overview of how OCS work and some of the things that I learned during this process. All right, so next screen. What is operational container scanning? Right, you can essentially get this from the docs, but I just wanted to set the context. This feature allows our users to scan container images that are in their Kubernetes cluster, right, and then present the vulnerabilities in their GitLab project, right? So underlying, it uses the Trivy scanner, right? But the difference that I initially was stumped on was that it doesn't share any code with the GitLab container scanning, right? So I was looking for the code for OCS in container scanning project, but I couldn't find it, right? Where it actually resides is inside the GitLab agent project, right? Here's a high level overview of how things are connected, right? This is our GitLab instance, right? In there you can actually activate a Kubernetes agent server, right? If you are running GTK, there's an option for you to configure and activate it, right? This is essentially what connects the GitLab agent to GitLab, right? So for customers who wants to use GitLab agent, they need to use a Helm chart to install this the agent in their cluster, right? And they also need to grant the agent cluster admin access so that the agent has access to all the cluster workloads in the cluster, right? Once this is installed and KAS is turned on, right, the user would need to configure certain configuration I'll go through later to allow like a particular project access to um, the cluster essentially, right? And so OCS, Operational Container Scanning, is part of GitLab Agent. It's a module within GitLab Agent. And if they configure container scanning in their GitLab Agent configuration file, that's how they can enable the scanning, right? And so this is the configuration portion. There are two ways that a user can configure operational container scanning, right? One way is through the agent configuration file. Um, Maybe after this, I'll put a link here. But essentially, this is a configuration file that's almost similar to the GitLab CI file, right? It resides inside the repository, and you can essentially tweak the fields here, and the configuration will be sent to GitLab agent. The other way is through scan execution policies, right? The format differs, but the main two fields that is essential are the cadence, right? And then the namespaces, right? Once this is configured, um, cadence essentially tells operational container scanning when to start running the scan, right? And namespaces essentially um, configures the agent to scan specific namespaces within the cluster. Okay, and then finally, this is the main gist or what I was hoping I had context in when I started working on this project, right? And this essentially describes the whole flow of how OCS works, right? So I took the configuration from the previous screen, right? This cron schedule essentially says that a container scan would run at midnight every day, right? And that it should scan for the default and kube system namespaces, right? So I didn't really draw out the detail here, but essentially when the configuration has been configured in GitLab, right, KS would send it to OCS, KS would send it to GitLab agent, right, and then the OCS module read it from GitLab agent and configure the cron worker, right? So let's say that it is 12 a.m. right now. What happens is that OCS would look at the namespaces that have been configured, and then it would take the Trivy container image and spin up a pod for each namespace, right? So yellow means a pod, right? And because we have two main namespaces, there's a default namespace pod and a kube system namespace pod, right? And this is the Trivy container image that Trivy maintains. And what we're doing here is that when OCS spins up the container, right, it's essentially passing in the namespace field to be scanned, right? And so for this one, the namespace field would be default, right? And so Trivy, the Trivy pod would go to the default namespace, look for all the workloads within the namespace, and scan it for vulnerabilities. There's one detail here that stumped me when I was working on this feature. That is that for controlled workloads, pods essentially, right? I.e., for example, this replica set, which would create and manage pods, right? They both share the same container image, right? Trivy K8, when it scans it, it would scan them separately, right, and come up with the same set of vulnerabilities, right? And those similar vulnerabilities would actually be reported back up, right? But what the additional code that we had to do that I missed out was to remove controlled pods from the vulnerabilities that have been found, right? This will ensure that there are no duplicated vulnerabilities. So this was a detail that stumped me. We covered it with tests, right? I just wanted to present it here just in case another engineer misses this out, right? And so once the scan is complete, right, the Trivy pod would its status would show succeeded, right? And what happens is that the operational container scanning module is listening for the succeeded status, right? And then it would go and read the logs of the Trivy container pod to then parse the vulnerabilities that was scanned here, right? And then once all the Trivy pods are done, it would then send up the vulnerabilities to GitLab, which is then presented in the GitLab dashboard. So yes, this is the general workflow of how OCS works. Adam, do you have any questions?
Yeah, the data that's passed from the Trivy scanner pod that is sent back to the GitLab agent pod through a log, right?
Yep, that's right.
Like the vulnerabilities, right?
Yep.
Okay, so and there's limitations on the size of that log, I
Yes,
believe.
so we added a limitation of 10 megabytes. So if the logs get too big, we don't want GitLab agent to crash, and that's why we kept um a maximum file size of 10 megabytes there.
And do we compress the logs before sending them?
We're actually not sending them. We are using the Go Kubernetes library to read the logs directly from the pod. So when the
Okay.
pod exits, right, the pod is not deleted yet, and the logs are still present.
Yeah.
Yeah, and we're using the Kubernetes API to read the logs.
Okay. But there was also some discussion of follow-up issues, I guess, of sending this information through HTTP by starting up a server.
Yep, that's right.
Yeah.
So
So, okay.
yeah, so thanks for raising that. There were some considerations here, specifically because the logs could present certain errors, which could cause the parsing to break. Because we are essentially parsing for a JSON format that contains the vulnerabilities. When I was working on another issue, it raised errors that was presented before the JSON body, which broke the initial implementation, right? So I've used projects to catch that, but that could still be brittle if ever there are certain changes to the logs which we can't really control, right? And so another approach that I've created a follow-up issue with is to modify this 3V scanner port. So instead of using the 3V image, the image, the container image that 3V maintains, we could potentially use it as a base, right? Add a script that that senses once the scan is done to send the vulnerability JSON file to the GitLab agent port, right? What needs to be done there is that in the GitLab agent port, we need to expose a service, which essentially is a HTTP endpoint that each of these ports know of, right? Which can then send the data back. So that way we don't have to depend on the logs. We can depend, I mean, it's a lot more robust. It's not as brittle as reading logs. But that also requires quite a significant refactor in that the way we parse the vulnerabilities have to change. We have to add a HTTP server here, right? And then we have to maintain the scripts and a Docker file for the scanner.
Yeah, cool. That makes sense. And yeah, it will improve it'll be less fragile in that case. But it seems that, yeah, I think you created an issue for this. But yeah, it seems like we will probably, I guess, stick with this implementation until we run into roadblocks or issues that would force us otherwise. Because if this works, I guess with the limitations, the size, if we run into a size issue where there's over 10 megabytes, I guess it's possible, but I don't know how common that is.
Yeah,
Yes,
I'm not
so
sure too, but that's possible. Yeah.
yeah, because there are also it increases the complexity significantly, because not only do you have to have an HTTP server, but you need to also have send the data from the Trivy scanner, and you need to retry in case it's down, and you need to still propagate those errors if the HTTP server is not responding, or there's significant complexity.
For sure. Yeah. The
Yeah,
synchronization
so
part is the toughest part, I think, of because now I'm essentially just waiting for the pod to complete by giving
yeah,
a succeeded status, right?
yeah,
But now with that new approach, how how to figure out whether the scan was done and whether a file was actually sent is could be a problem.
yeah. Cool. Well, it sounds sounds like we're in a good state right now. And uh yeah, you created an issue for the follow-up in case we did want to go down this road. So
That's right.
yeah.
Yeah.
Um
There was another follow-up issue that I created as part of this work. It's a similar process that we face with GitLab container scanning. That is, whenever 3V updates its version, right, we need a process to update it. And so right now, what happens is that I added type definitions in the OCS implementation, right? Whereas the previous version essentially imports 3V files in here, right? And because of that, we need every time we update the 3V scanner image, right? We need to make sure that the types have not changed. I think we also need to have a way to test that the logs don't break, right? I think previously, Adam, you mentioned the end-to-end test. I think it's all captured inside that issue, and I think it's something that we can potentially work on to make this whole process more robust when we are updating the version.
yeah, thank you for creating that issue. I took a look at it, and it looks good. But yeah, it seems like that would be we get some benefit from that because we would be able to diagnose um, and solve issues quickly as they come up. And we would need to have tests either way if we were to switch this to using that HTTP server method method. We still need to have those
True.
tests. So it seems like that's a good next step.
Yep, that's true.
Yeah.
Yeah.
And this image right here, this diagram, I think you said you were going to document this in the GitLab agent code.
Yep, that's right. So let me see if I have it on my screen. I don't. It's actually a mermaid diagram. Um, it's not as nice as this because I cannot control how the graphs are manifested, and so I redrew it. But yes, I'm creating a merge request after this to get it merged into OCS, into GitHub Agents repository, and so it's easier for other developers to discover it.
That's great. Yeah, because I'm sure this would have been quite helpful for you when you
Yep.
started working on this.
Yeah, for
Um,
sure.
and yeah, it's a shame that we can't have the same amount of control through Mermaid because this diagram looks pretty clean. And I know it's going to be with Mermaid a little bit all over the place.
Yeah,
Yeah. Um, but easier to maintain than
definitely.
this. Yeah.
Yeah, definitely much easier.
Yeah. Um, awesome. Thank you for thank you for doing that presentation. It looks great.
Cool. Thank you.
I guess we'll stop
Yep.
stop the recording.
Yeah, I'll stop the recording.